It's September 26th, 1991. Behind you, a giant glass door seals shut in the Arizona desert. There are 8 of you, and the plan is simple enough to explain in one sentence. For the next 2 years, you are going to live inside a manufactured world. Not a spaceship, not a bunker, a world. On one side, there is a rainforest. On another, a desert. There is an ocean with a reef, wetlands, farmland, living quarters, machines, soil, insects, crops, animals, water, and air. Outside the glass is the Sonoran Desert. Inside, it's everything you need to keep the 8 of you alive. At least, that is the bet. They call it Biosphere 2, because Biosphere 1 is Earth. And now, you are about to find out whether a small, sealed version of Earth can carry human life on its own. At first, it feels like you have been handed the most beautiful survival game ever built. You wake up under glass with a rainforest a walk away. You can hear water moving through a landscape that was assembled from real soil, real plants, real microbes, and thousands of living relationships. But that beauty hides the real challenge. The glass is not the experiment. The experiment is every invisible exchange behind it. Every breath has to lead somewhere. Every crop has to become food. Every scrap, every waste stream, every insect, every bacterium, every person has to fit inside the same loop. If one part slips out of balance, there is no enormous planet outside the wall to absorb the mistake for you. This is why Biosphere 2 mattered. It was not built just to look like science fiction. It was a test of closed ecological life support. Could people, agriculture, technology, and several ecosystems keep working together long enough to teach us something about life beyond Earth? For the first few days, the answer feels like it might be yes. There are jobs everywhere. You tend crops. You manage water. You record what the system is doing. You harvest, cook, clean, repair, and watch. You do not get to treat food as something that simply appears in a store. You have to understand the chain that produces it. A seed becomes a plant becomes a meal. The parts you cannot eat must still return nutrients to the system without poisoning it. And all of that has to happen while the world around you keeps changing. The farm is not decorative. It is your pantry. Across the 2-year mission, the agricultural area supplied roughly 4/5 of the crew's nutritional needs. That is an extraordinary achievement. It is also not enough to make the problem easy. The crew's reported diet averaged around 2,200 calories a day. Crop pests reduced yields. Farming and food processing consumed about 45% of the crew's time. And in the first months, the shortage becomes personal. You are not watching a documentary about hunger. You are planning your day while hungry. You are tending the plants that decide what you can eat next week. You are counting on a harvest that does not care about your morale. Over the mission, crew members lost roughly 10 to 20% of their body weight, most of it in the first 6 months. The food was nutrient-dense, but a carefully designed diet is not the same as a comfortable one. And then, while you are focused on what is on your plate, a more frightening number starts to move. Oxygen. At the beginning, the air inside contains about 21% oxygen, the familiar concentration of Earth's atmosphere. Month after month, that number falls. At first, no dramatic alarm announces what is happening. The world still looks green, the farm still needs tending, the glass still holds. But after about 16 months, oxygen inside Biosphere 2 has dropped to around 14%. That is comparable to breathing air with the oxygen fraction of an elevation near 17,000 feet. This is the moment when the fantasy changes. You are not trapped by an enemy outside the dome. You are trapped by an imbalance inside it. The first explanation people imagine is a leak. But the deeper problem is alive. The soil had been loaded with organic material. Microbes in that soil consumed oxygen as they broke it down. Meanwhile, the carbon dioxide they produced did not remain neatly available for plants to turn back into oxygen. Some of it reacted with exposed concrete, forming calcium carbonate. So the system was losing oxygen faster than photosynthesis could replace it. The machinery had not simply broken. The ecology was doing exactly what ecology does, following countless chemical and biological rules that do not care about the story you wanted the experiment to tell. Eventually, the managers face a choice: protect the ideal of a materially closed experiment, or protect the people inside it. Liquid oxygen is brought in from outside. It keeps the crew safe enough to continue, but it changes the meaning of the mission. If a miniature Earth needs outside oxygen, can you still call it self-sustaining? That question becomes part of the experiment's legacy. Not because the oxygen injection makes every other result worthless, but because it reveals how hard the original promise really was. And oxygen is not the only thing that refuses to follow the plan. In a natural world, Species do not merely sit beside each other like exhibits in a zoo. They compete, feed, reproduce, die, and alter one another's chances. Inside Biosphere 2, that process becomes brutally visible. Surveys before closure found no single ant species dominating the facility. By 1993, a species called the crazy ant, Paratrachina longicornis, had surged to extremely high numbers. The lesson is not that ants are villains. The lesson is that a sealed ecosystem does not stay frozen at the moment you design it. It begins changing immediately. Small advantages compound. One species finds more food, another loses ground. A pest damages a crop. That crop changes the food plan. That food plan changes the people. And the people are also part of the ecosystem. By now, there are only 8 of you. You have to keep working beside the same people when the work is exhausting, food is limited, the air is wrong, and the project outside the glass is under pressure too. A later account by people involved with Biosphere 2 describes factions forming over personal chemistry and disagreements about how the mission should be run. Outside power struggles made the strain worse. So yes, the relationships inside became seriously divided. But that is not the entire story. The same account says the crew kept functioning. They still had to farm, monitor the system, process food, and manage a world that could not be abandoned just because the people in it were angry. That may be the most unsettling part. There is no pause button for a closed ecosystem. You cannot postpone the harvest until everyone feels better. You cannot ask the soil microbes to stop respiring while the group has a meeting. You cannot put fresh oxygen back into the air with a better attitude. On September 26, 1993, the first 2-year closure mission ends. The crew has made it through, but Biosphere 2 has not proved that humanity can easily build a second Earth. It has shown the opposite. Earth is not just a container full of life. It is a vast, buffered, ancient system with oceans, forests, soils, atmosphere, weather, time, and an almost unimaginable number of living relationships. Inside Biosphere 2, a few tons of soil, a shift in gas chemistry, a crop pest, or a conflict among 8 people could change the future of everyone inside. The failure was never that humans could not build a beautiful glass world. The hard part was discovering that beauty is not balance. You can build the rainforest, you can build the farm, you can build the ocean, you can seal the doors, but you cannot simply command a planet to become alive in the right way. And if we ever try to live on the moon, Mars, or somewhere farther away, that may be the real lesson of Biosphere 2. Survival will not depend only on rockets, glass, or machines. It will depend on whether we understand the living systems that keep every breath possible.